All right, we are finally to the last of our 4 periodic trends, electronegativity. This is a concept that we're introducing here and we will come back to multiple times, particularly in our unit on ions. So again, here's our standard. We're now hitting the last one, which I can explain the trend for electronegativity on the periodic table. All right, so here's an electronegativity chart. You'll notice that it's like a periodic table. The biggest thing on it is you have these numbers. These numbers here are the electronegativity. Okay, they're on a scale normally up to 4. Fluorine is normally the highest at 4. You notice though that there's this Na here for the most of the noble gases. We'll talk about why that is, but just be aware that it's there, that they don't. And yes, I know it says krypton and xenon have 3 and 2.6, but most of the time, for the purpose of this class, we treat those as also being Na. Na stands for not applicable, which means these guys do not have electronegativity. So electronegativity is a measurement of the tendency of an atom to attract a bonding pair of electrons. So if you have really high electronegativity, it means you're really capable of pulling electrons. If you have low electronegativity, you have trouble pulling or attracting electrons. You don't really want them. So electronegativity, high electronegativity, they really want electrons, and low electronegativity means they really don't. Okay, that normally means that atoms that have high electronegativity are normally anions because they're gaining electrons. Atoms with low electronegativity normally form cations because they actually don't hold their electrons very well. They try and lose their electrons. So here's the trend. What is the trend for electronegativity as you go down a group? Well, you look at the numbers, okay, and what do we see? The electronegativity decreases as you move down a group. This should make sense because of atomic radius and the number of protons, okay? When an atom is attracting electrons, they're attracting it to its outermost energy level, okay? As you go down the periodic table, you get bigger and bigger, which means where you're attracting the electrons to are further and further away from your nucleus. So it's harder and harder to pull electrons because they are so far away. So francium is the largest element on the periodic table. It's got the largest atomic radius, which means it has the most difficulty attracting electrons because the electrons are being attracted so far away, or they're going so far away from the nucleus, which has got the protons, which was actually attracting the electrons. So I hope you can see where this is going. If the largest element on the periodic table has the lowest electronegativity, what do you think the smallest element on the periodic table does? So what's the trend as we go from right to left? Well, you can just look at the numbers and you see that it goes from 0.98 to 3.98. So as you go from left to right, the electronegativity increases, it goes up. Okay? And again, remember, electronegativity is the ability of an atom to attract electrons. So remember, fluorine is one of the smallest electrons, and it's the smallest atoms, and it's one of the most electronegative because it's really, really small. So it's really, really easy for it to attract electrons. Okay, you'll notice though, like technically neon is actually smaller, but the problem is neon is a noble gas. Noble gases, remember, they're stable. They don't want any electrons, so it actually balances itself out. So they actually have no electronegativity because they do not attract electrons. Okay, so to sum it up, electronegativity, as you go down the periodic table, the electronegativity goes down. So that's why francium is the lowest electronegativity, and fluorine is one of the smallest atoms, so it has the highest electronegativity. This also has to do with the cations and anions. Remember, metals are more likely to become cations. To become a cation, you have to be able to lose an electron. So they actually want to lose electrons, not gain them, while the nonmetals all want to become anions. They want to get a negative, they want to gain electrons to become like a noble gas. So it makes way more sense for them to be able to have the ability to attract them. That's how they can become like a noble gas. So that is electronegativity.